Hello guys, my name is Saddam and welcome to my channel. In this video, we are going to talk about motion in plane polar coordinate system. This is another video on the lecture series of Kleppner and Kolenkow, and if you are new to my channel, please subscribe, and if you haven't seen my previous videos, please go and check out my playlist which you can find in the I button. So let's get started with our today's video. Motion in plane polar coordinates. The rectangular or Cartesian coordinates we have used so far well suited to describe motion in a straight line. So we have the motion in a straight line, but the motion in some kind of geometrical. For an example, motion in a straight line. What does it mean? A block is moving in some kind of particular one direction. We are calling it in a straight line. Maybe you have the motion goes this way, maybe this way. These are the few examples of motion in a straight line. Suppose a bicycle you are riding, it is going in front of this thing. It is also example of motion in a straight line. But here there is some involvement of rotation here. Means the wheel is kind of a circular thing. That means that all the spokes or the wheel itself is actually going round and round and round and round. So suppose you have some object which is actually going round and round and round and round. We are calling that kind of motion is called circular motion. Okay, so we had a motion in a straight line, but we had some involvement of motion which is being circular type. So the problem is that how do we figure out if a body is moving in circular motion, what could be the velocity, how we can figure out the position at certain time, and how can we define acceleration in a very efficient way? Well, that's what today Toby suggests, that motion in plane polar coordinate system. Then your first question will be that what is the meaning of plane polar coordinate? Plane polar coordinate. The motivation of doing this kind of coordinate system is of that the motions which involve in a circular motion. Like for an example, you have something like simple pendulum. They have some kind of periodic motion. Or we have a solar system where you got a sun, we are here in earth, and they go around and round and round. This is also a particular example of circular motion. Again, the rotation of galaxies, they are also involved in a circular kind of motion. So there are so many things which is involved in a circular kind of motion. The system, for an example, the motion of a motor, it is going around and round and round and round. So that's why they are written as RPM, rotation per minute. So in order to understand what does it mean, how can you figure out acceleration, velocity and position at certain time, we need to understand how to construct mathematics in efficient way. And to do that, we are going to introduce polar coordinate system. How we are going to do it? Now, as we have hinted that this polar coordinate system, actually polar coordinate is actually linked with circular motion. And what is the property of circular motion? The property of circle, let's figure out what is the property of circle. The property of circle is kind of very simple one. You have the some center, and about center there is a radius, which is constant, and it is making an angle theta, and this theta for complete circle is 0 to 2 pi. So if you're going to move from here and you come right here, it means that you have complete one revolution of, and you are making an angle of 2 pi, means 360 degree at the center with constant radius r. Now, how can we help? How does it help in our physical system? For an example, suppose you have a stone and you are tying with some kind of a string, and you are holding here, and you are just moving this. So this will move in a circle thing. So again, this is one example of circular motion. Now you may ask, so this has the block and it is moving in a circular trajectory. a radius is attached with a string. And one may ask that what is the velocity, how can you find the velocity position at certain time, and what could be the acceleration. So if I am plotting an coordinate system x and y, and for any object, to find the location of any object, what we can do, we just figure out that from the origin is my here, what is the coordinate of x and y. Now we have this particular relation like r square is equal to x square plus y square. And this is a very interesting thing. The radius is fixed because no matter your object is here, here and here, the radius is fixed. So we have the circle, for circle we have this particular equation and we are calling it this constraint equation. Why constraint? Because this equation is actually saying you that any body is moving in a circle, because the coordinate of x and coordinate of y, if you are going to be square and sum them, the distance would be constant. So it is we call constraint equation. Well, we can also write it. We can transform this equation by choosing a very interesting thing, like can we choose like a, let's say cos theta, and y is equal to a sin theta. So if I'm putting this in equation 1, we can write here like a square cos square theta plus a square sin square theta, which is a common, and cos square theta plus sin square theta. Are you understanding the point? Now this is 1, therefore r square is equal to a square. So the radius is equal to a square, and if a is your radius, then from here it will say that the position, it is having the constant distance from origin to this one, which is your a. So to identify any position, we'll transform every equation like x is equal to a, or let's say maybe r is a right choice to do it. Okay, so let us say we can write here r cos theta and y equals like r of sin theta. Now here you can see that r is your some particular kind of radius and theta the angular displacement. Now you may ask that what is this angular displacement? If you will observe here, the object may at some time is here, may sometimes is here. It is making some angle, the change in angle, let's say this one. At some time this angle would be this one. So the radius is not changing, but theta is itself changing. So theta is maybe particular, it is the function of time. So x will become a function of time, because in coordinate system your x and y is always changing. So we can say that x is r cos theta, and particularly theta is a function of time. And r is not function of time because if circular motion, because the radius is not changing. So we have to figure out that which are the quantities which will be the function of some time, r of sin theta. Got it? Now we understand from the concept of vector that if we have some kind of axis like x and y, and we see this is your r vector, and if it is making an angle theta, okay, so we see that r is equal to r of cos theta in x hat direction and r of sin theta in y hat direction. Can we write this down? Equation number 2. I am not here using this equation. Forget about equation 1. It is for constant equation. So I have already shown you what is the constant equation, means that the radius has to be constant. So to identify some position of any object, we know how to write the position, because at some particular we see the x distance will be r cos theta plus r sin theta, and we know theta is some kind of dependent on time. Well, what you can do here, you can write dr vector over dr, some constant r. So because r is not a function of time, therefore I am differentiating with respect to some parameter which is your r. Therefore this guy will be cos theta x hat plus sin theta y hat, and this is equal to r hat. You know, r vector over magnitude of r will going to give a unit vector of r. So this is giving you the increasing direction of r. Okay. Now what we can do here else, is dr vector. It is not now r vector. Now here we have r hat. So let me just proceed with r hat. Okay. So what we can do here, simply write r hat is equal to cos theta x hat plus sin theta y hat. Now theta is a function of time. What else we can do? We can write here dr over d theta is equal to minus of sin theta x hat plus cos theta y hat, and this is we are calling as theta hat. Now you may ask that what is this theta hat? Now you see in the figure, this is your r vector, and from this point the increasing direction the unit vector is r hat. Now in xy system, like we have this coordinate system like x and y, and x dot y is your perpendicular. X hat and y hat will give you 0, means that x hat is perpendicular to y hat. Similarly, if we are writing in a polar coordinate system, then we have these two quantity like r hat and theta hat in polar coordinate system. So r hat is this one, therefore theta hat will go this side, theta hat. So we have started from x hat and y hat, and now we are rewriting everything in terms of r hat and theta hat. So theta hat from here, from x, it is making theta. Now this is again perpendicular to here. So therefore from here to here it will making pi by 2 plus theta. So you can mark it like this is your xy coordinate system and this is your again y thing. So from here we can find this guy. So this is pi by 2 plus theta, and the total angle is 180. So pi minus pi by 2 minus theta, which is your again pi by 2 minus of theta. Got it? So theta hat we can write here one component theta hat cos theta. So theta hat magnitude cos of, now this angle is pi by 2 minus theta, and now this angle will be for theta component theta hat again magnitude sine pi by 2 minus theta. Now cos pi by 2 minus theta in this direction, this is your minus x hat. So it will be minus sine theta x hat, and sine theta sine pi by 2 minus theta in y direction is cos theta y hat. So this is nothing but your minus your theta hat. Now we can check that r hat and theta hat is perpendicular to each other. They will gonna vanish. The dot product will gonna vanish. Now we have this interesting property. Okay, very good. So we see we have this following thing like r hat cos theta x hat r hat this is your magnitude r sine theta y hat. Again similarly we got theta hat is minus sine theta x hat plus cos theta y hat. So we have set of equations. Now I have already told you we have to find velocity and acceleration, because the motion means that we have to find what is the velocity and acceleration of any object. How to do it? You will use the velocity vector is nothing but the position vector and derivative with respect to time. I know what is your r vector. R vector is nothing but r cos theta, let me write here r cos theta x hat plus r sine theta y hat. So what is the definition of velocity in a polar coordinate system? So let us just use that. What if r is, now in general r is your also time dependent, and theta is, as we have already told you, that theta is again time dependent. Now you may ask that how r can be theta dependent. Well, there are several cases when the body is moving in a circular direction but they are increasing in some particular direction. So a body is moving in this way but there is some kind of increment in this fashion. For an example, you are riding a bicycle. A wheel is always going round and round and round, but you are going in forward direction. So they have both the motion, like the motion in straight line as well as the circular motion. So therefore there is involvement in r vector is also changing, because it is changing from one point to another point and another point. So in general r can be dependent on time, but we can always go in the specific case where r is independent of time. So before we do a special case, let us just generalize things, that r is also a function of time and theta is again it is a function of time because it is a circular motion. So we have to find the velocity. Therefore r is also a function of time, so we can write here dr over dt, it is again magnitude cos theta, plus r d by dt of cos theta and xi. Similarly we can do here d by dt r sin theta plus r d sin theta over dt y hat. Good. So far is good. Now if any quantity, if I am having this, suppose there is a quantity and derivative with respect to time, I'm going to use this notation q dot. Similarly I can write here r dot cos theta plus r, and d cos theta is minus of sin theta, so I have to write here minus r sin theta, and theta is a function of time, therefore it will be theta dot. So far everything is fine. Similarly again r dot sin theta plus again r cos theta, theta dot, that is y hat. Great. Now we can see here a very nice pattern, that r dot cos theta x hat plus sin theta y hat. Okay, we took common this guy, and again we are seeing something very interesting, like if I'm taking r sin theta, so r theta dot is my outside, I have minus sin theta x hat plus cos theta y hat. Okay, now cos theta x hat sin theta y hat, I had something like r vector by r hat is cos theta x hat sin theta y hat. This is your r hat. Wow, amazing. So I can write here this is your r hat plus r theta. Now this is reminding me of something. Something is which? A theta hat is minus sin theta plus cos theta. Oh, so I can write here theta hat. Therefore now v is completely written in terms of r hat and theta hat. There is no x, there is no y. So this is the transformation from one coordinate system to another coordinate system, and this is the, by default we have the definition of velocity. Definition of velocity in polar coordinate system. So do you have any problem so far? Everything is fine? Clear? Okay, my hands, I'm tired while just doing this definition. Okay, first of all we have to do a little bit, mess up that. Okay, is this formula correct one or is this not? Do you have anything to check this formula that yeah, this is correct one or wrong one? Well, what we can do here, you see the velocity. Velocity is r dot r hat plus r theta dot theta hat. I have already told you, for the case if I'm talking about that r is something like constant, it is not independent of time. Okay, because r is only changing here, it can change this direction, not here, 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 here. It is means that if r is 5 centimeter, 5 centimeter, 5 centimeter, the change can take place like 5.1, 5.2 in this one r hat. That is the meaning of r hat. The changing can take place in this direction, and theta hat means that the theta, this change in this direction. So r is constant, therefore r dot is 0 independent of time. I got something r theta dot theta hat. Yeah, very good. So I think that it is fine, because d theta over dt is your omega. We are calling it the angular velocity because there is a change in angle, therefore we got this angular velocity. So v is equal to r omega, that is theta hat, in increasing direction of theta. Yeah, we have already read in class 9th that v is equal to r omega. So whatever we have found about velocity, it is perfectly all right. Okay, do you have any problem? I don't think so. You may have any kind of problem. So you see, to derive all these things, we follow that what could be the r cos theta, r sin theta and all these things. But with the definition of this thing, we can easily write, for an example, a cycle, for cycle thing or any kind of coordinate system. No, not coordinate system, any type of example. For an example, in solar system, we can apply this formula directly to find the velocity of any particle which is moving in circular coordinate system, or even if for a spiral thing. And if your radius is also changing, therefore there is a velocity, we call it linear velocity. Now we can say this is a very much generalized velocity, like v is equal to r dot r hat plus r theta dot theta hat. You see, r dot r hat, it is coming from linear velocity. So this velocity, you cannot say it is a linear velocity. It is a generalized velocity, where your linear velocity, linear motion is also involved, and theta that is angular velocity. So by default, if I am taking this prescription, by default your velocity is generalized in a manner that it is containing linear velocity of the object as well as the angular velocity of an object. I hope this is clear. But we are not done here. Why? Because in order to find the motion of any particle, we have to understand what is the acceleration. And acceleration is a vector quantity, and therefore we have the following prescription to define it: dv over dt. And we have recently found that dv over dt is nothing but r dot r hat plus r theta dot theta hat. And I have already chosen r is function of time, therefore r hat is also function of time. Theta is function of time, so theta hat is also function of time. Got it? So you cannot just write that, okay, r dot is function of time, r hat is not function of time. No, my dear, because r hat is also changing because it is increasing direction at which your r vector is increasing. In which direction your r vector is increasing, therefore r hat is also function of time. Theta is also increasing in anti-clockwise direction, therefore theta hat is also a function of time. So we have this job, like first of all we follow the chain rule, d by dt of r dot r hat plus r dot dr hat over dt. For your, I'm writing this down because for the sake of practice for you, so that you may not get angry at me that, oh, you don't do this kind of mathematics, basic mathematics. So I am just following this. Again, I am going to note this thing r double dot, because now dq dot over dt is telling you that this quantity is again derivative with respect to time. So it is, you follow the second order derivative. So the second order derivative with respect to time, second order derivative with respect to time, r dot r hat plus r dot r hat again dot plus dr over dt, which is again r dot theta hat plus r theta double dot theta hat plus r theta dot theta hat. Now I am gonna forget this equation, really I'm telling you that, because this is a very long equation and I can't remember it. So let me just copy and paste, otherwise you know what is my condition. I can simply forget. Okay, here we have buddy. Therefore I have this interesting thing, like, this is your acceleration. Now you may ask, how can you find this guy and this guy. Well, we have this following thing here, because we have already found what is your r hat, so I'm going to write like r hat is cos theta x hat plus sine theta y hat. So r hat dot will be minus sine theta dot x hat plus cos theta dot y hat. Okay, theta dot, if I'm taking common, then minus sine theta x hat cos theta y hat is nothing but theta hat. So you see the change in this radial vector, increasing direction change, it involves in this omega times your theta hat in theta direction. So I can write here r hat, this one is good, r hat is theta dot theta hat. Okay, now here we have some involvement of r dot theta hat. Again, no change take place, theta hat plus now theta s prime. Yeah, this one is good. So I know what is your theta hat. Theta hat is minus sine theta x hat plus cos theta y hat. It is correct? I think so. So theta dot will be minus cos theta dot x hat. Then this cos theta is minus sine theta, which is your theta dot y hat. Now if I'm taking minus of theta dot outside, you are left with cos theta x hat plus sine theta y hat. Am I correct? Now cos theta x hat sine theta y hat is nothing but this guy minus theta dot r hat. It is great. It is great news. R theta dot minus r, that's what I told, minus theta dot r hat. So minus r hat theta dot, which is the correct one, minus theta dot r hat. You see my condition. So we have this radial factor, like one component in radial direction and another component in theta direction. It may seem a very big deal, but it is actually not, and it is more like r theta dot square in radial direction plus here we have theta dot theta hat. So 2r dot theta dot plus r theta double dot theta hat. Now you may ask that what is this shit? What is this implying actually? You see, here is an acceleration which is linearly involved. Here is an acceleration which is angularly involved. There is again the acceleration producing because of the velocity at which it is having some linear velocity, as well as it is actually spinning in its axis, which is from v into omega, and it is from pure angular acceleration that it is moving, how fast it is accelerating. So it is your angular acceleration. This corresponds to Coriolis force. Now this is your linear acceleration, and this is your acceleration. We are calling it centripetal acceleration. Now you may ask, what is this centripetal acceleration? Now this acceleration is your generalized quantity. It is not like acceleration you are writing that A is okay, A just like the A we have written. No, my dear friend. When your theta dot is 0, then here theta dot 0, here theta dot 0, here theta dot 0, then you will get r double dot. It is linear acceleration. Now if your r dot case 1, if your r is not independent of time, r is constant, therefore you will be left with minus r theta dot square. Okay, and this guy will go to hell like r hat, and again this guy r theta double dot theta hat. Means that it is saying a very fundamental equation. It is very interesting thing. It shows that there is a centripetal acceleration. Means that if you are tying up any kind of bead here, and you are just holding this hand, and if it is rotating like this, and its velocity, it's keep on changing. Means that, for an example, here its velocity is 1 meter per second, and here it is 2 meters per second, it means that there will be some kind of angular acceleration. It is actually having this, that is theta double dot prime. Now if there is an uniform angular velocity, therefore theta double dot will go to 0 for angular uniform velocity. Now if your angular uniform velocity is not there, therefore theta double dot is there. So we have angular acceleration. So if the body is moving, having this angular velocity is constant, means that we will having only left with r theta dot square, and this r theta dot square is, what is this? For an example, let's say we have this centripetal acceleration. What does this mean by centripetal acceleration? A is equal to minus r theta dot square r hat. This says that this r hat, the direction has changed. Centripetal means that this acceleration is towards the center, and if I am multiplying with masses from here to here, we will have the force, and force in the radial direction or in the central direction, that if any bead is moving in this kind of orbit, circular orbit, it has a very beautiful force which is acting in the center, and we are calling it mr theta dot square. And what is theta dot? Theta dot is nothing but v is equal to r omega, and theta dot is nothing but omega. So I can write here mr. So omega square is v square by r square. I think you know this formula, mv square by r, and this is your centripetal acceleration. And there is again one force is arising, r theta double dot. So r theta double dot, again it proportional to angular acceleration, let's say alpha, and if I am multiplying with m, so mr. Now what is this? We are saying that omega dot, and when this omega dot happens, this acceleration shows that if you are applying any kind of force, because if you are applying some kind of force here, then its velocity keeps on changing. Okay, and if velocity keeps on changing, therefore here the angle will again accelerating first, because this angular velocity will keeps on changing. Therefore it says that there is acting some torque on this object, there acting some torque on its object, and the torque is such that this is the bead and this is a perpendicular distance r, and here your m, and some acceleration is applying this way, because I have already told you that this velocity, here is a velocity, and angular velocity happens there, and this is velocity. So this says that this torque is equal to m, the perpendicular this thing, and therefore we have some kind of acceleration is acting here. Okay, so I can write here r, ma is nothing but force, see, but this is again perpendicular, so it will be like r cross f, because whatever the acceleration, it is angularly. Now you see the nature here, r theta dot dot theta hat in theta direction. Okay, so in this theta direction means that this is going like this, and maybe here like this. So as if you are screwing something, means that suppose something is there, and if you are twisting this thing like this, so this object will move on this way. So theta hat says that this guy has to be constant. Therefore mra, because the velocity is changing, therefore there is produces some acceleration ra, but we don't know what kind of m into a is force, but what kind of relation is there, since there cannot be dot, because ra is producing torque and they are having the perpendicular distance, which is theta hat, and theta hat, the direction is, because it is moving in this fashion, so as if you are rotating this handle like this. So it is right hand thumb rule, and if you do this, so the object means if it is moving in this way, this direction, so if you are screwing this way, it is going in upside z direction. So this is having this z direction rotation or theta hat, so it is coming out of the screen. So there is a vast, we have started with a very few simple understanding of velocity, simple understanding of position, how we can express in a polar coordinate system. Then we have defined velocity, and we have found that velocity is something like that, and this velocity is generalized. Because it contains the linear velocity as well as angular velocity. And then we are saying that r is again, r may be the function of time, and theta is again function of time, and then we use the simple definition of acceleration and we do derivative of velocity with respect to time, and we found this kind of relation, a very generalized relation, and we found that this has some interesting property, because this acceleration is containing something linear acceleration, centripetal acceleration, Coriolis force, angular acceleration, and we thought that if maybe there is no any Coriolis force, we have this linear acceleration. Let's say linear acceleration is not there, therefore we are only say that r is not function of time, therefore we have centripetal acceleration, and as well as if this particle is having some kind of force again which is actually involved in changing in velocity, this we call tangential velocity. Okay, so if tangential velocity keeps on changing, means that there is acting some force on it. So in centripetal force, if it is moving in a object, we have this radial force, we are calling it centripetal force, mv square by r. So this has the direction here. But if you have that angular velocity is also changing, means that omega is changing, which involve in changing direction, we say, like just like in rotation. We have already seen how the cross product works. We have found that the another term is nothing but a torque, and torque is defined as r cross f. So we have built several relation out of very very toy type model, and we have figured out so many things in a one go. So that's why this kind of things is very important to understand the physics. And in theory physics, it is absolutely gorgeous beauty, it has amazing beauty, and as we understand, if you are a theoretical physicist, you probably have enjoyed it. So if you have enjoyed it, please don't hesitate to like and subscribe and help me to grow my channel. My channel contains more than 200 videos, and it has several kinds of video you can watch, share to your friends, and you can send me your most valuable feedback. This is Saddam Leonardo Cap signing out with this video. Thank you very much.